So for the last part of the dev room, we have talks on like real-time processing, fast data, streaming. So we're switching topic again. I'm happy to introduce William. He's going to talk about big data and fast data.
Thank you. So, my name is William. I work for Pivotal. I work in the Geode engineering, or Gemfire, where it's actually the name of the commercial product. That's the region of the open source project named Geode. And the idea is to talk about how you can integrate a system that is really focused on big data, such as Greenplum, and operate with fast data in memory using an in-memory data grid such as Geode, and then you can do the transactional workloads in Geode, but then if you need to do some machine learning or some more complex querying, then you can do that in Greenplum. So how can you make this integration easier, right? So when we are talking about big data, right, most of the times you have a problem where you have a single system or a single process or a single machine that has to deal with a lot of data. And it's a tough problem, right? So let's imagine that this guy here, he wants to somehow get all these balls and pass them through some tubes, right? One approach, which would be this. So parallelization is one way to do it. It works, but up to a limit. And if you're still thinking that it's a single guy doing all that work, it's going to take a lot of time. So what we are trying to suggest here as an alternative is something like this. So let's get a bigger pipe, right? So a mix of both is actually the ideal scenario, and that's what we are trying to do with this integration between the both products, right? So I'm not sure if everyone was here when the introduction to Greenplum happened, but a nice way, I guess, to summarize is that it's a highly distributed also MPP database. There is this idea of master node, multiple master nodes, and multiple segment nodes, and the data is spread across all these nodes, partitioned, right? And there is also the idea of using a specific protocol, right, called GPF-dist, that is also available in Greenplum, that you can then import low data, right, from files or from other systems very, very, very fast, because the protocol, right, the binary, it's smart enough to map all the NICs and identify all the NICs available on that machine, and then map those to files or split the files if needed, and then load that, creating like a fake or an external temporary table, for example, and then suck the data into all the segment nodes if needed, right? So it's very fast, but you are still doing that, leveraging, and you're still made to be bounded, right, with the file and the I/O, the cost of I/O that you would have to load that file from this. So we looked at this and said, okay, how can we solve this problem, right? So the other project that we have at Pivotal, right, or no, it's actually an Apache project too, called Apache Geode, is focused on in-memory data. So you have the notion of a cluster, you have multiple nodes, and we do have a lot of customers that are already using this in production, and they have a lot of transactional workloads. They deal with big data in memory as well. So why not leverage this other project here and integrate both? So there is the concern, of course, about when you're dealing with data for sensitive data, like, I don't know, financial industries or let's say retail, right? That you don't want to lose data. So in the case of Geode, since the project actually started to work on the needs of the financial industry, right? There are like a lot of features that is already part of the project that tries to solve this problem of data loss. So for example, whenever you put an entry inside the cluster, you can specify the number of replicas of the data you want in the cluster. So let's say you want 2 replicas or 3 replicas. It's going to share or put those replicas in other nodes of the cluster. And if one of these nodes fail, given the number of replicas you specify, the cluster is going to reestablish that, copying the data to another node that is available, right? So it's going to keep that consistent. If you happen to have some execution that you want to do in this data in memory, right? And you can do that using plain Java code, and if that fails, you can restart. So you can specify that even the function that you are executing, operating on this data, has some level of failover as well. It deals with network partition, so split brain scenarios. It has a built-in support for that. You just enable a flag and you have network partition detection. And it also supports WAN replication, right? So this is very nice because one of the complaints about many systems or many customers that are using systems that doesn't have this feature is that, okay, I have this database or this system running on one data center, but now I also want to have DR capabilities in another data center, or I actually want to operate both data centers at the same time. So how can you do that? So we offer WAN replication as well. And since it's in memory, right, people sometimes get scared and say, well, it's in memory. Well, what happens if the node fails or crash? Am I going to lose all the data? So although it's in memory, you can also specify this to be actually persistent on disk. And we then have some smart algorithms to recover that data from disk. So even if your entire cluster is down, you can recover all the data from disk in a very easy and fast way. And then, of course, we do load balancing for clients and whatnot. So to put that in perspective of numbers, so these are 2 use cases that we have. They're still using Pivotal Gemfire, but just for you to understand, Pivotal Gemfire got entirely donated as Apache Geode. So it's the same code base, it's the same system, works the same way. So China Rail and Indian Rail, if you actually do the math, you have here a lot of transactions, concurrent users and whatnot. But another way to look at those numbers is by the population. So if you just combine here, we like to joke internally and say that, well, we are kind of responsible for 36% of the world population, like public transportation in a way. So, but at the same time, people may not know about Gemfire or Geode. So that was also one of the things that started, that triggered the idea of sharing the code and making it open source. So that's to popularize a little bit more, right? So getting back to the original problem, right? The idea then was that we could still leverage the GPF disk, but instead of loading that from disk, right, from files, we'll just suck data from memory, from Apache Geode. So there is this concept of a locator, which is like a load balancer node. So through the locator, you can discover the other nodes in the cluster for Geode. So we discover and say, I have 4 nodes here. As soon as this connection is established with all those nodes, from this point on, each segment on Greenplum would then start talking directly with the server here on Geode. And then hopefully, this is a work in progress, by the way. This is still under development. We have an alpha of it, but it's going to evolve. But we are still working, for example, trying to solve the problem of hashing or partitioning the data here, because the way Greenplum partition data is not exactly the same way as Geode partition data. So the ideal solution would actually be if we could get to the same schema of partitioning here and really match one-to-one, like one server on this side talking to one server on that side, so they talk about the same data set, right? Moving on a little bit, this is an internal joke, as you might know. EMC got sold to Dell. So here's the scenario, right? Ideally, this presentation would have a demo, so I'm not able to do that demo because of technical reasons. So there's a VM involved and whatnot, and the VM is not really behaving well. But so imagine this scenario, right? So you have a credit card transaction, so sensitive money. You want to do that very fast because, of course, you don't want people waiting. Everybody hates waiting for the card transaction to actually happen. So we are going to operate and do that everything in memory and still be safe about it because it's transactional. You can do transactions in Gemfire or Geode. And that data then is going to be offloaded to Greenplum. And in Greenplum then you can run MATLAB, which is a data science machine learning open source project as well that was internally created at Pivotal, but now it's actually part of Apache and incubating too. So then you can do that, and based on the metrics and data you can collect about the historical data set in Greenplum, you can then do that and identify a possible fraudulent transaction, for example. Another way to actually look at this architecture, right? So first, if you actually look at this and you say, that's Pivotal Gemfire, Pivotal Greenplum, or Pivotal Cloud Foundry, right? So let's actually not do that because we're, of course, talking about open source. So everything here is open source. The solution is pretty much the same. So the demo that we built, and the source code will be available in GitHub as well. So have a POS simulator, so a POS simulator and a web console. This guy is going to use the REST interface available on Geode to send some data to Geode. Geode then is going to parallel do the distribution to Greenplum. And then in Greenplum, MATLAB would be running, like from time to time, some algorithms to calculate what's the possibility or what's the probability of having a fraud in a particular zip code, for example. So then, based on that, let's say I'm an insurance company, right, or I'm a credit card company, I can charge by a different amount or have a different level of risk based on the zip code because I know that that zip code has more possibility of having frauds, for example, or something like that. So that can happen here, or you can have your data science team to implement a custom algorithm to process the data here as well. And then our web client there, which is just a map of the United States in this case, right, will show and receive all the updates from Geode through a feature called event subscription, right? So instead of keeping pulling whenever I want a new data set from there, it's actually going to be just monitoring, and as soon as a new entry lands in Geode, that data is actually going to send push to the web client, right? So here is an example of the UI. So I would rather actually show that live if I could, but the idea is that we have like a bunch of green dots popping up in the UI all the time, and whenever a transaction is identified as possible fraudulent, it's going to be red. That's pretty much it. And another way to actually look at that, so here are like a collection of zip codes, and the ones in red, or the bigger ones, right, are the ones that actually had more fraudulent transactions. So we are, of course, open source. Looking forward to have contributions and any comments you guys might have about the solution we are proposing for this problem, or even for other current pending items that we have in our JIRAs, both for Geode or for Greenplum. So if you're interested in Java and distributed systems, you go to Geode or C++, Greenplum, although we might still be releasing native clients for Geode as well, so some C++ there as well too. The source code for the demo that I'm supposed to be showing here will be available on this GitHub here, and there are other demos that are available even for Geode or for Greenplum. And one quick note too is, of course, that we are hiring, so if you are interested in working with us in any of these projects, let us know. Some links and references, and yes, grab stickers if that's your thing, like mine. Thank you very much. I'm open for questions. For this integration, well, the current the major problem we are having now is with the hashing. So we are trying to understand how we can keep that consistent. Given the way we serialize data and the way Greenplum serialize data, we are kind of trying to match that. And also, of course, because we are Java, we're C++, there is some challenge there when we're doing some data translation and whatnot, but that's one of the things. But I'm pretty sure it's doable, like with time. So we'll keep working on that.
Using Spring at all to move the data around?
Not really. We are using Spring as part of the REST API, for example, in Geode. There is a Spring Data Gemfire with the Spring Data Geode project as well, so that's more of a way for an end user to talk and play with Geode, but not really for this integration. Because we're really concerned about performance, and so we are really doing like low-level Java, if you may think, like avoiding.
If I don't know neither of those two databases, what should I compare it with?
So Geode is an in-memory data grid. So if we're familiar with, let's say, Hazelcast, nope. Coherence. Okay, good. So Coherence, Hazelcast, Ignite, maybe Geode. So it's a class of systems that they got very, very popular around 2000, 2003 or something like that. So the project, the Default Gemfire project exists as for 10 years already, right? And the problem they were trying to solve was that databases were not scaling fast enough, and the financial industries would like some extra performance for their transactions. So they created this kind of class of system called in-memory data grids, where you can scale and operate in a similar way as a database, but just in memory, right? But then, of course, just in memory may not be enough, because what happens if you lose data? So then we start working with replication, distribution, and then even allow persistence to disk as well. But still in a different way, in a slightly different way than traditional databases like Greenplum or Oracle, something like that.
Yeah, that's interesting. Actually, that's the concept of first-level cache applied to big data, basically. Do you plan to extend that to feature like you can find in MDM, in master data management, to create some views on top of different tables, for instance? Do you plan to go in that direction?
Well, we actually started working on an HDFS connector. So the same way we are uploading data to Greenplum or to this, we will do that with HDFS. It's currently in a, how can I say, it's paused. The source code is available. It's part of Geode already. You can already do, but we are not really including our next release. But as soon as we actually start getting more feedback, as like this would be really interesting, we can start like working again on it. That's kind of, we are just waiting for some feedback. That's the same thing, for example, for Spark. We have a Spark connector as well for Geode, and it's considered in a beta state right now. We are just waiting for some feedback on it so we can kind of recover and start like iterating more and increasing. But that's not completely one thing.
And would Geode be suitable for graphs and for time series data as well, or?
For time series, definitely. For graphs, I guess, I mean, we don't really don't have any native support for tags or anything like that yet. So that would be kind of something that, let's say, if we have the integration with Spark, I would definitely let that happen in the Spark side. You just consume the data from Geode or something like that.